Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome all of you to virtual remedial classes of 2025, which are sponsored by Mewa. My name is Mr. Kassim Hammad, and I am teaching physics today, the date of 18th September 2025. And today's topic is the Newton's laws of motion, the final parts. We are basically winding up on this topic. Tunamalizia hii topic sasa, so that we can go to other things. And remember, since I started virtual remedial classes of 2025, for those who have not have not yet seen my other videos, or you were not with me from the start, nimekuwa nikiongelea kuhusu paper 1 topics za physics, so don't be confused with the order of the topics kwenye nimeenda. Sasa I decided that for this virtual remedial classes of 2025, I will talk about those paper 1 topics which disturb people a lot, especially when it comes to questions. So that's why I decided to start with linear motion, then Newton's laws of motion. Sure. Welcome all. So this is Newton's laws of motion, final parts, and this is the table of the contents. So first of all, we will start with a worked example of conservation of linear momentum. Tutaanza na swali ambayo ilikuwa inaongelea our past topic. Our past topic ilikuwa ni linear collisions. So tutaanza na kama maswali mawili hivi ambayo ilikuwa ikiongelea mambo ya conservation of linear momentum. Then discuss about friction. Yeah, friction is also a very big part of this topic. Then mwisho, the last thing that we'll discuss about ni viscosity. Sasa, welcome all of you. So here we have a worked example of linear momentum question. How do we deal with it? So the question says, let's start with number 2 over there. Kwamba a resultant force of 12 newtons, so a resultant force of 12 newtons acts on a body of mass 2 kilograms. Let us just draw this thing over here. So the body is 2 kilogram, 2 kg, and the body is 2 kg, and a force of 12 newtons is acting on it. A force of 12 newtons is acting on it. What is the change of momentum of the body? So what is the change of momentum of the body? So remember, per the second law of linear momentum, mv minus mu over t is equals to force. That is the second law of linear momentum of the second law of linear momentum. So but hapa tayari tuko na force. Sasa tayari tuko na force. So since tayari tuko na force, it's a very simple thing. Sasa but by the way hapa wametaja pia time. The time taken for the force to act on the body. Kwamba hii force ili act on the body in 10 seconds. Yeah. If this force acted on the body in 10 seconds. That is a very important thing that we'll use in this question, ambayo tutatumia katika hii question. So hapa itakuwa change of momentum. Sasa change of momentum ambayo haijulikani, let us just call it delta p, because kama nilivyoambia in physics, momentum can be given a symbol p. Sasa delta p over t is equals to force. Sasa so delta p is not known. Sasa so delta p, the time taken for this momentum to change is 10 seconds. Sasa and all that is equals to a force of 12. So if we want the change in momentum, we simply multiply these two things. So it equals 12 times 10. 12 times 10, which will be 120 Newton seconds. Remember, I told you the SI unit of momentum can be Newton seconds. So it's Newton seconds. That is the SI unit of momentum. So another question hapa kwamba a minibus of 1,500 kilograms. So let me just draw it here. A minibus of 1,500. Let me just write it here. 1,500. So traveling at a constant velocity of 72 kilometers per hour. Sasa hapa they've spaced things a bit. Wameleta velocity in kilometers per hour. So 72 kilometers per hour. Here it must be converted before we continue. 72 kilometers per hour. If we convert it usually using the normal method of multiplying by 36 divided by 10. Sasa tukiconvert hii 72 kilometers per hour to meters per second, it will be 72 times 10 divided by 36, which will be 20. So actually, this thing, instead of writing 72 kilometers per hour, we just write 20 meters per second. 20 meters per second. Yeah, that is the same thing as 72 kilometers per hour. So it collided with a car, and that car, its mass yake was 900 kilogram. Yeah, 900 kilogram. The impact takes 2 seconds before the two moves together at a constant velocity for 20 seconds. So your change in momentum, in short, change in momentum happened within 20 seconds, within 2 seconds. That is something to be noted. Yeah, because this thing will be related to force. Yeah, the change in momentum took 2 seconds to happen. That's before the two moved together at a constant velocity for 20 seconds. After collision, these two became one thing, whose mass was 2,400 kilograms. And hizi mbili zilimerge. So zilipomerge, their masses also merged and became one thing, which moved at a constant velocity for 20 seconds. So calculate the common velocity. So the common velocity will be as simple as saying 1,000 change momentum before collision is equals to momentum after collision. So 1,500 times 20, and remember the car will not have any momentum because the car ilikuwa stationary. It was not moving at all. So 1,500 times 20, that's why car had to iweke is equals to the momentum of both of them times the velocity after collision times, so 2,400 times v. So 1,500 times 20, that is hiyo itakuwa 30,000. Sasa 30,000. So 30,000 is equals to, as you can see here, 2,400 v. So if you divide 30,000 and 2,400, we get the velocity to be v to be 12.5. Yeah, v to be 12.5 meters per second. 12.5 meters per second. That is the first question. The second question was asking the distance moved after impact. Remember, let me write something here. We discussed the next question. Let me wrap this first question over here. So the distance moved after collision will be simply as velocity after the collision times time. Remember, these two moved together for 20 seconds. So 12.5 times 20. 12.5 times 20. I think it will be 250, but let's just calculate 12.5 times 20. Yeah, 250. It will be 250 meters. These two will move 250 meters after the collision. So the third question was the impulsive force, meaning the force that caused changing that caused that was caused in the collision. So let me look at something. Just a moment. So here we'll just look at the change in momentum for either of those two vehicles. For example, the bus. We can use an example of the bus. The bus, its initial momentum was 1,500. The bus only 1,500 times 20. Yeah, that was its initial momentum. Then its momentum after the collision became 1,500. Remember, we are considering the bus only times 12.5. Yeah, times 12.5. So that will be the change in momentum. So if we minus those two, so if we minus those two, we'll get because 1,500 times 20 will be 30,000 minus 1,500 times 12.5, yeah, will be 11,250. That is the change in momentum for the bus. The bus's momentum changed, the bus only, that is, not the car, not both of them. The bus momentum changed by 11,250 Newton seconds. So kwa vile tushapata change in momentum, tunaweza pata the force produced during the collision. The force produced during the collision is simply change in momentum divided by time. Change in momentum divided by time, ambayo itakuwa hii 11,250 divide by 2. Yeah, 11,250 divide by 2. So if we take 11,250 divide by 2, it will be 5,625 newtons. Yeah. 5,625 newtons. That was the force produced during the collision. So, which is a very big force. It is enough to damage a car very badly. So the last question. The last question is saying that the change in kinetic energy. Remember, this is an inelastic collision. Many collisions are usually inelastic collisions. Kinetic energy haikui conserved before and after the collision. So hapa, how do we know the change in kinetic energy? It's very, very simple actually. So let me just look at something here. So the total kinetic energy, let's say kinetic energy before the collision, or kinetic energy 1. Yeah, kinetic energy 1 was the kinetic energy ya ile bus ambayo ilikuwa ni a half times 1500, I have times 1500 times 20 squared. Yeah, times 20 squared. And but if you multiply it well, you'll get that it is 3 times 10 power 5 joules. Yeah, 3 times 10 power 5 joules. That is the kinetic energy before the collision. The kinetic energy after the collision, after these two collided, will be a half times the total mass of the moving things after the collision. About 2400, 2400 times their total, their velocity, their combined velocity, which is 12.5 squared. Yeah, 12.5 squared. So if you multiply these two, it will be 1.875 times 10 power 5 joules. Yeah, times 10 power 5 joules. So change in kinetic energy, yeah, change in kinetic energy will be this minus this, kinetic energy 1 minus kinetic energy 2, which of course will be 1.25 times 10 power 5 joules. Yeah, times 10 power 5 joules. 1.25 times 10 power 5 joules. That will be the change in kinetic energy. You minus 3 times 10 power 5 minus 1.875 times 10 power 5. If you minus two things like this, which are in standard form, you just minus the first digit. 3 minus 1.875. Sasa. Then you add your times 10 power 5 joules. Baada usha minus. Sasa. Let us not spend a lot of time in these questions. If anyone has a problem on conservation of linear momentum, you can tell me in the comments. So let us discuss about friction. Yeah, laws of frictions. So friction basically, as we know from right from primary, it is a force that acts on rough surfaces. Kwa mfano, you have a block. Hiyo block unaiburuta on a table. So what happens ni kwamba the friction between the block and the table inafanya ile block iende pole pole. So it's a force that opposes motion. Yeah. And it is situated between the surfaces of two moving objects if they're in contact. So here there are some laws that define how friction works. So the first one says that friction is always parallel to the contact surface and it is in the opposite direction of the force, tending to produce or producing motion. So if friction, kwa mfano, we have a table here, and then we have a block of wood, and this block of wood is moving at this direction. The friction, it is always parallel to the surface, contact surface of the thing that is moving. And it is in the opposite direction. It does not act on the same direction. So this will be friction, and this will be the force causing the motion of the block. Then number two, friction depends on the nature of the surface and materials in contact with each other. So how rough is the surface also affects friction. Sasa if the surface iko rough sana, friction pia itakuwa nyingi. Na if the surface is smooth, friction itakuwa kidogo. Number three, kinetic friction. Kinetic friction is friction that acts on an object when it is moving. Hiyo ndio inaitwa kinetic friction. So kinetic friction that acts on an object while it is moving. Tayari ishaanza kutembea. Sasa is less than static friction. Static friction is friction before the body starts to move. Kabla ile body haijaanza kumove, ile friction ambayo iko kwenye ile body ndio inaitwa static friction. Sasa then number 4, kinetic friction is independent of speed. Sasa yeah, basically friction ambayo ina ina affect kitu ambayo tayari ishaanza kumove, it does not depend on speed. Sasa then number 5, friction is independence, yani it does not depend on the area of contact. Hata kama the two surfaces ziko na lot of contact area, zimegusana by a very big area, friction does not depend on that area. Number 6, friction is proportional to the force pressing the two surfaces together. Basically, the force moving that thing and the force of friction, they are proportional. So the force causing the motion is equals to something called a coefficient and friction. So, no, sorry, it's actually the other way around. What do you say? Let me just write it nicely. So that's really frictional force is equals to a coefficient of friction, na hiyo coefficient ya friction ina depend on how rough the surface is times force causing the motion. Coefficient times force causing the motion. Sasa write it nice. Yeah, coefficient times force causing the motion. That's how friction, the force causing the motion relates. Sasa so how is friction applied? Why do we discuss about friction? Friction is applied in many ways. Inakuwa applied in a matchstick. Kibiriti haiwezi waka bila friction. It is applied in chewing food because food cannot be chewed properly without friction. It is applied in brakes. It is applied in motion of motor vehicles, bicycles also, not only motor vehicles. Any moving thing cannot move comfortably without friction. It is also applied in walking because walking will be very, very hard if it were not for friction. So how do we reduce friction? Number 1, rollers. Rollers are basically just some cylindrical logs. Can be made of wood, can be made of metal. This is how they look like. You can keep them between an object and a surface. Yeah, and sorry, I do this thing. Badly. You can roll them between an object and the surface. So ile roller haito affect ile, itafanya hii kitu imove haraka zaidi kushinda normal. Sasa rollers, they reduce friction. Number 2, ball bearings in vehicles and machines. Yeah, in some machines they are usually, katika zile vitu ambazo zina rotate kuna vitu zinaitwa ball bearings, huwa zina reduce friction a lot. Sasa they're just some small balls, small metallic balls, huwa zinawekwa katika rotating parts of a machine. Number 3, lubrication and oiling. Yeah, oiling objects, kwa mfano kama door hinge, why it reduces friction a lot. Sasa, so you can see there's an example here of how friction is applied. A wooden box of mass 30 kilogram. Let me just draw it here. So this box is 30 kilogram. So it rests on a rough floor. So it rests on a rough floor. Then you are told that the coefficient of friction between the floor and the surface is 0.6. So coefficient is equals to 0.6. Coefficient is 0.6. Calculate the force that is required to move the box. That is number one. If a force of 200 newtons is applied to the box, what acceleration will it move? So number A, force required to move the box. The force required to move the box will be equals to uh, coefficient times the weight of the box. So coefficient times the weight of the box. Let me delete this a bit. To just move, yani to make it move, not to speed it up. So coefficient times weight of the box. So remember tuko na mass yake. That means tunaweza pata weight yake. So coefficient ni 0.6. Hiyo ndo coefficient. Times weight yake itakuwa 30. Weight yake itakuwa 30 times gravity ambayo ni 10. So 30 times 10 ni 300. 300 times 0.6 itakuwa 180 newtons. That will be the force needed to just move that thing. To just move the box. To make it move. That's how. So then you are told that a force of 200 newtons was applied to the box. So a force was applied which was higher than the force required to move the box. Required to make the box to move. So what acceleration will it move? So remember, the friction is 180. We got the frictional force. The frictional force opposing the motion is 180 newtons. And the force applied to move this box is 200 newtons. So first of all, tunapata kitu inaitwa resultant force. Resultant force itakuwa 200 minus 180 which will be 20 newtons. Hiyo ndio itakuwa the resultant force. Then remember hii 20 newtons itafanya hii box speed yake iongezeke. So 20 newtons is equals to mass times acceleration, ambayo mass ya hii kitu ni ngapi? Ni 30 kilograms, ndio? Mass ya hii kitu ni 30 kilograms. So 20 newtons is equals to mass which is 30 times acceleration. So divide by 30 on this side and divide by 30 on this side. Divide by 30, divide by 30. So if you divide by 30 on both sides, tunapata acceleration inakuwa 0.67. Sasa 0.67 meters per second square. If anyone did not understand, unaweza sema kwenye comments. Sasa don't be shy. The last thing in this topic ni viscosity. So viscosity basically it is the friction inside a fluid. Friction inside a fluid. For example, air. That thing we call air resistance that makes us not to move fast in air. Hiyo tunaweza ita viscosity. Because air is just a fluid. So tumeambiwa viscosity in a liquid. Let's say you have a liquid over here. We have a liquid. Viscosity in a liquid decreases as temperature increases. So increase temperature hii liquid, let's say ukiheat. When you heat it, increase temperature yake. So ukiheat temperature yake ikaongezeka, viscosity yake pia itapungua. So when a body is released in a viscous fluid, it accelerates. It accelerates. Nakumbuka this body it accelerates due to gravity. Gravity ndo inaifanya hii kitu accelerate. Mg, the force known as mg or the weight of the object inaifanya hii accelerate. Then but after some time it stops accelerating. Sasa. Now the reason why it stops accelerating is because of something called upthrust. Yeah. Upthrust is basically from forward. It's the force that makes objects to float. So there is something called upthrust inamake kitu float on the fluid na kuna gravity. Sasa. So there are two opposing forces. So the moment this thing stops accelerating, sasa, the point at which this thing stops accelerating, sasa, that means the upthrust is equals to mg. Yeah, the upthrust is equals to mg. That is when this thing stops accelerating. Hapa amesema f is equal plus u is equals to mg, which oh yeah, it makes sense by the way. It makes sense kwa sababu hapa it is not just upthrust making this thing to slow down. Sasa kumbuka pia kuna viscosity, kuna upthrust na pia kuna viscosity. Let us call it F. Sasa ile friction ambayo hiyo liquid iko nayo. So the friction plus upthrust zinafanya hii kitu iende polepole, but hii mg inafanya hii kitu iende haraka haraka. So the moment they are equal, this thing achieves something called terminal velocity. Terminal velocity meaning velocity yake haiongezeki after hapo. It remains the same. Hata kama hiyo kitu itaendelea kushuka, but velocity yake inabakia hivyo hivyo. Sasa, thank you. Have a nice weekend.